Hey, Jody here. Thanks for watching another video from weldingtipsandtricks.com. Doing some MIG welding today, some light duty MIG welding, 11 gauge 2-inch square tubing, and I want to talk about welding 45 miter cuts and the direction of travel and the bead placement to keep them straight, to keep them at 90 degrees. If you're making a box, you know, you get it all tacked up nice and square, if you got enough tacks on it, it's pretty easy to keep it square because that box is rigid. It's got everything locked in place. Can't move around a whole lot. But occasionally you got to weld something in its free state, just a regular L angle bracket or something like that. Now all of a sudden it makes a lot more difference on where you place your beads and the direction of travel and all that. So that's what we're talking about today. Let's do it. In an earlier video, I was welding some really thin wall square tubing, 2-inch, and the wall thickness was less than 60 thousandths, so less than 1.6 millimeters. And I was using 0.25 wire on this thin wall tubing and 18 volts, 305 inches a minute, and it worked out pretty good. Nice crisp starts, and these little downhill runs just zipped up, nothing flat. Doesn't take much heat to do a downhill run on thin wall tubing like that, and you get good crisp starts with that 0.25 wire. I'm still using 0.25 wire for this project today. Mainly I'm going to be talking about bead sequence to keep a 90-degree angle 90 degrees. So I'm getting TIG tacks on here. I'm going to be MIG welding this right out back of the shop, but I'm getting it TIG tacked up. And I like to knock a flat spot on these sharp corners. If you cut it on a chop saw or whatever, you're going to have a sharp corner there, and there's really nowhere for the weld to go, and you wind up melting that sharp corner off, and you get a ropey high bead. It just goes better to knock a flat spot on it first. So that looked a little cold, and it actually was, and the reason is because I didn't adjust the settings for this thicker tubing. This is twice as thick as I was doing before. But let's talk about bead sequencing. I weld the outside corner first because that generally doesn't pull things anywhere. And then I weld these runs downhill like this from inside to outside. Always remember that weld metal shrinks, and it shrinks in the direction of travel. It's kind of like lacing a boot, and it's accumulation of stresses, and it'll pull in the direction of travel a little bit. And the reason I'm welding in the other direction is because this weld tends to pull more than any of them, so I get everything locked in place before I make that. Now I make these little series of looping E's here. It's just kind of my go-to technique. You don't have to do that. You can just do a straight pull. Here's a little example where you can maybe see it a little clearer. I'm pausing at the top to you know, just kind of prevent any undercut or anything. Just a little pause at the top of the motion, but it's a series of looping E's or U's depending on how much you want to build up. And that works for me these days better than anything because it just plays the light and lets me see where I'm going better. Totally not necessary to do that motion. I just like to do it. And if you do it evenly, it provides a decent looking weld. Now you can also just do a straight up drag like this. Nothing at all wrong with that. It just doesn't play the light around for me, for my eyes. I'm getting a little older now. Looping it around, just a little bit of motion plays the light around, helps me see where I'm going. So that's the finished joint on the square tubing. The settings were just a little bit cold. I thought I was dealing with thin wall tubing again, and come to find out this was 11 gauge. But I decided to go ahead and do a cut and etch on one just to see if those low settings did any good, and they didn't do badly, mainly because this tubing was all nice and clean and shiny. I removed all the mill scale. That makes a big difference. Now, occasionally you've got to weld a freestanding L, so there's no other corners locking it in place, making it rigid. And so bead sequence and direction of travel and bead placement now makes a bigger difference because this is free to move around. I'm getting a TIG tack in the middle there, thinking that wouldn't move things because I didn't really have any gaps or anything, and it was squared up with that wide base square. But I do have just a little bit of gap there now at the end of that blade. That's a 0.45 wire, so I'm going to put a tack right here on the inside, and that should pull it inward a little bit. Weld metal shrinks, remember that. So place your tacks and your beads and everything where you want to, knowing that weld metal will shrink. And usually you can use that to your advantage by placing your tacks to draw a part where you need it to go, or if a part's slightly out of square, you can place your beads in your direction of travel to pull it back in square. That's pretty close. I've got a little whisper of a gap there on the end of that blade, so I'm going to put another tack right here on the inside of this
this L-shaped part, and that should pull it in just a little bit. It's a very small tack. And again, I'm just putting TIG tacks on this thing because it's convenient for me. And I'm going to take it out back and weld it up. So I'm going hotter this time, now that I realize I've got 11 gauge tubing here. And that's going in a lot better. That doesn't look so cold. I'm just doing a little wiggle, mainly again because of my eyes. It just helps me see where I'm going. So that one bead on the outside really generally won't pull a whole lot, and it didn't do anything. It's still perfectly square, or just, you can fit a piece of paper behind that blade out there on the end. This bead again, I'm going to run one side here going from inside to outside because again, weld metal shrinks in the direction of travel. It's kind of like lacing a boot. Let's check that for square now and see if that moved it at all. I'm not clamping it down to anything here. I'm just welding it out in free state. So we'll see what we've got there. And really, didn't really move it at all. It's still pretty much like it was. This is my wide blade La Square that I sell on the store. I really like it. It's handy having that wide base on there. So the second bead, same thing. Starting on the inside and going in the direction of travel to the outside, because if anything I want it to draw in that direction, because that last bead is going to pull it in more than any of these things, and it's going to be hard to do it. It's going to be hard to pull it the other way. Easy to pull it inward, hard to pull it the other way. So again, I can just about put a piece of paper in there. It's pretty darn square, but that stayed that way the whole time with all those beads on there. Now I'm going to weld this last bead in place. And I'm going to use this same little technique, this little series of U's or looping cursive E's, whatever. Just depends on how far you go back into the puddle, how much you want to build up. If you make a U, you won't build up as much. Your travel speed will be faster. If you make an E where you loop back into the puddle, it slows you down a bit and you build up a little bit more. I must have done a little E there because it built up. Here's the problem with regular squares. You got that corner on there and you got a weld on there. It won't go in there. So this is a good use for a Harbor Freight square. I'm going to knock the corner off of this and turn it into a welder's square. I highly recommend doing this to a cheap square so you can measure things like this. But that's dead nuts right there.
And then the bartender says, "Why the long face?"